look at the diagram carefully, we can see that there are many variations that can be made. What changes can be brought about if I change the intensity of my incident light? What happens if I change the frequency of this light? And will there be any changes in the photocurrent if I change the potential of the circuit? If I increase the potential of the collector plate, what happens then? All these variations were made separately and studied in a detailed manner. So there were 4 important variations that we will be discussing today. One is the intensity of the radiation. The second is the frequency of the radiation. And the third will be the changes brought about due to the potential difference. And the fourth will be the material with which this emitter plate is made of. Let us start with the intensity. It was observed that photocurrent was directly proportional to the intensity of the incident light. That means whenever the intensity of this incident light was increased, the photocurrent also increased. So the graph of photocurrent versus the intensity is a linear graph. Let us now keep our frequency and incident of light constant. I will now change the potential of my collector plate, that is A. What will happen now? Suppose I provide a positive potential to this collector plate A. Now it was observed that the photocurrent increased. All the electrons were drawn faster towards the collector plate, and there was one point where there was no further increase in the photocurrent. All the electrons that were present in the emitter were collected by the collector. So this point where there were no more electrons coming out from the emitter plate and the photocurrent was constant is called as the saturation current. We can now define the saturation current as the maximum photocurrent of that setup. So here what I did was I gave a positive potential to my collector plate A. What will happen if I give a negative potential? When I give a negative potential, we see that the electrons do not reach the collector plate. Isn't it very obvious? If you have a negative potential at the collector plate and the electrons are also negative, we very well know that 2 negative charges will repel each other. Therefore, the electrons which had very high energy only could reach the collector plate, whereas the electrons which had lower energy did not reach the collector plate. This negative potential was called as the retarding potential. And there was a point where we further increased this negative potential, it reached a point called as the stopping potential. At this particular potential, not a single electron could reach the collector plate. So we saw that the photocurrent is also 0. If there are no charges reaching the collector plate, so it means it's obvious that there is no current flowing through the circuit.